Welcome to Friendly Math 101. Today our lesson is on function notation in application problems. Let's take a look at our first example. Here we have a graph that displays the relationship between the total cost and the distance in miles of a taxi ride, and you're being asked to evaluate t of 15. 15 represents our input values, or our x values, so that represents the number of miles. We're being asked to find the corresponding y value or output value to this particular input value. So we have to find 15 here, go up to our graph, and at this point the y value is 25. So we could say that t of 15 is equal to 25. If you're asked to demonstrate or to explain what t of 15 equals 25 represents, you would say that it represents a taxi ride that is 15 miles, will have a total cost of $25. What you want to include in your explanation is both your input and your output values. You want to include your two variables, and you want to address the context of the problem. So in this case, it was a taxi ride. Here we have another graph that represents the relationship between the water level and the time in hours of a pool that's leaking. You're being asked to evaluate W of 6. Again, 6 is our input value, or our x values. We have to find the corresponding y, which is 1. So W of 6 equals 1. And what this represents, you could say that after leaking for 6 hours, the swimming pool will have 1 foot of water left or remaining. Again, you want to include both your input and your output values and your variables and a little bit of the context of the problem, which is the swimming pool that's leaking. That concludes our lesson on function notation from application problems. If you have any questions, please feel free to leave those questions in the comments section below. And for more math tutorials, subscribe to our channel, Friendly Math 101.